Hey everyone, thanks so much for joining us today. Another one of our demo sessions that we do on Tuesdays. Today we're joined by Jason Lichtman from Autodesk, who's going to be talking us through a bunch of Fusion 360 basics, a bunch of ways you can use Fusion 360, how it interacts with 3D printing, as well as a little update on the Netfabb software as well, which is also part of Autodesk's CAD suite. Throughout the session, I'm going to pass it off to Jason here in just a moment. Please feel free to put any questions in the Q&A box at the bottom of your video window. Just hit that, hit ask a question. I'll be keeping an eye on those questions all throughout the session, and we'll have some time at the end where I can pass some of those questions over to Jason. Also, if there are Formlabs focused questions, I'm happy to jump in there as well. You may just get a typed answer rather than a spoken one while we're going here. No polls on this session, so don't worry about that. Lastly, just want to mention as well, always feel free to join the conversation over at our forums. It's forum.formlabs.com. Got an amazing community of users over there doing all sorts of cool stuff. So whether you're having a particular issue, you want some advice, you're looking for ideas, inspiration, come over and join us. It's an awesome place. Yeah, we'd love to get your questions there. So with that, I will stop sharing my screen. I'll hide all my stuff, and I'll pass it over to Jason, who will jump in from here. So let me just stop my share.
Excellent. Thank you so much, Dan.
Yeah.
I'm just going to go and share my screen as well.
There we go.
Hello, everyone. My name is Jason Lichtman, and I'm going to be your host today to talk about Fusion 360. A little bit about me, just so you know who your host is going to be for today. I am a technical specialist for Fusion 360 at Autodesk. I'm a mechanical engineer, or a mechanical engineer, if you will, by background, and I have quite a bit of experience in industry designing consumer products. These days, I do work at Autodesk, and I specialize in Fusion 360 and talk to customers to teach them about how Fusion 360 can help their business. Now, we have an agenda for today with a lot of really fun stuff. So I'm just going to give you the agenda so you know what we're going to cover. Some of this is going to go pretty fast. And so don't forget that if you're watching this already recorded, you can always slow me down. Or if you don't think I'm fast enough, you could always speed me up too. I'm going to start with an overview of Fusion 360, and then we're going to talk about all the ways you could design something. And there are a lot of different ways. That's why it's called Fusion 360. After I cover 6 of the different ways you could design in Fusion, I'm going to show you how you can output a file for 3D printing on your Formlabs printer. I'm going to give you a preview of a new workspace that doesn't yet exist. It's in development right now that we're calling Paramesh. And then I'm going to turn it over to my colleague, Andreas, who's going to talk about Netfabb. So let's jump into the really good stuff. What is Fusion 360? Well, Fusion 360 itself is a CAD, CAE, and CAM solution. It's intended to be the next generation CAD platform, cloud connected at its core, making collaboration easier, data management easier, and just to make life easier. Whether you're going to be new to CAD or you're a professional who's using CAD for many years already, we're trying to make it so that you can adopt Fusion 360 and just have a great experience designing your products. Be able to do that more efficiently than ever before. So why does Fusion 360 exist when Autodesk already has Autodesk Inventor? Well, if you look at the world we live in today, we live and die by these things called smartphones. And it's just a little bit different than the type of phone you might have had when CAD was first existing. Something like this. This was actually my Nokia phone from way back when. And so we're trying to make a platform that's going to be modern, right? Trying to be able to make collaboration and design, everything else seamless. And so we started from scratch about 6 years ago. And Fusion 360 is incorporating technologies from other aspects of Autodesk all into one platform so that you can design, like I said, more seamlessly. Now, when it comes to design, I'm going to cover 6 different ways you could design. So let's actually share my screen again. And I'm going to start off with parametric solid modeling. So let's go into Fusion 360, and here you could see an example part. This particular part is an assembly jig, and I know a lot of the Formlabs customers are using their Formlabs printers to print exactly parts like this. So this assembly jig was designed using solid modeling techniques. You could see at the very bottom here what we call the timeline, which is the recipe for designing this particular part. You can always go back to the very beginning and change something, like in this case, change the sketch, which shows that the center to center distance between those two holes that you saw in the final model right now is 3 inches, and I could change that to 4 inches. It updates the sketch, and the best part is when you hit finish sketch, it'll update the entire 3D model. So every single one of these steps that occurs after the step before it, which would be to the left, is going to use the previous step. So it builds upon itself, and that's what parametric really is all about. Now, most users out there start off with solid modeling. Solid modeling is much easier to get a hold of, but when you start to get to really complex shapes or parts that have uniform wall thickness requirements, surface modeling can be very important as well. So let's jump to another parametric model, this one being a surface design. And here you could see a vacuum form packaging example. Right, so this is going to be holding what looks like 40 different parts, all in a plastic vacuum form tray. And this particular part, being a vacuum form tray, needs a uniform wall thickness. And the best way to design something like this typically is going to be through surface modeling. Surface modeling is a little bit more advanced than solid modeling, but can easily be grasped, just takes time and practice. In this example, we also have a parametric design. You could see the timeline right here at the bottom. And actually, I should have shown this from left to right. That's the direction that this timeline actually works. The icons here are orange instead of blue, just indicating that this is a surface model. And this surface model is also parametric. Now, just so you could see another way that you could design, instead of going back into your sketches and just changing a certain value or going into a feature and changing a value, you can also go into something that we call the parameters table. You could find that under change parameters here under the modified dropdown. And here you could see a list of what I would call specs or parameters that drive this entire design. And so I can change different values here, like the length of this object that I'm going to be packaging. Instead of 20, I'll make that 21, and it'll go and update my entire design. Right? That's the beauty of parametric modeling. So it'll go and just recalculate everything. Can you go into your individual sketches and change different values? Absolutely. But if you want one place to be able to change everything, you could do that here under this parameters table. Now, the next technique that I want to show you for designing, I think is really handy. It's called direct editing, sometimes called direct modeling. And direct editing and direct modeling, it's all about being able to take a design and be able to edit it directly. The most common example for that is going to be bringing in what we call a dumb CAD file, meaning a CAD file that comes from some other software and you don't have the history for how that model was created. So you don't have that parametric sketch or parametric feature to go and edit, and yet you have to make some pretty serious changes to it. Direct editing or direct modeling is the best way to do it. So let's go and take a look at this file. This is a step model that was imported from some other software. I don't even know where it came from. Doesn't matter to me, but I need to make changes to this model. So I see that first and foremost, it's not aligned correctly with my coordinate system. So I can come in here under Modify, Align, and I could just go and realign this part. So we'll just go and select, let's say this bottom edge and the origin. And now I have my model realigned perfectly. That's looking great. But now I need to go and make some changes to this design. So for example, I want to take this logo, the BT Industries, and I want to get rid of it because I'm going to put my own branding on this design. All I have to do is select the text itself, hit the delete key, and it's gone. That's the beauty of direct modeling. Now you could do that for all sorts of things. Like I have a whole bunch of fillets here that are all sorts of wonky. I'm going to try to get rid of those. Maybe I'll recreate new fillets. Maybe I won't. But to get rid of them, all I have to do is hit that delete key as well. Now, it's not just about deleting things. You can also change existing geometry. So I have some holes over here, and I want to change the size. I can select the hole, and using what we call the press pull command, I can change this to a new radius value. So instead of 1.125, maybe I'll make that a millimeter. Maybe I'll make that half a millimeter. Point simply being, I don't have to create sketches and extrude. I can simply modify the existing geometry. One more I'll show you before we move on. This one's my favorite. I have two ribs on the back side of this model, one right here and then one right over here. And I did a finite element analysis in Fusion 360, which by the way, you can find here under simulation. We have 9 different study types that are all included within Fusion 360 for you to do your analysis to make sure your part is going to be strong enough. It's not going to vibrate too much under resonant frequencies and a whole lot more. But let's say I've already done that analysis and I only need one rib right down that middle. I could go in and create a sketch and use that sketch to extrude cut through both of those ribs, create a new sketch to go and draw a new rib, and then extrude that new rib. That would be 4 steps. In this case, we're going to go and simplify things. I can go and select the original rib on this side here. We'll go and select all those faces. Again, hit that delete key to get rid of it. But instead of doing the same thing with the other rib is actually already the right size. I'm going to go and use modify, move copy right over here. I can select to move bodies, or I could even move individual faces. So I can select the faces of the rib itself, choose to rotate it, and I have to pick some sort of axis to know what I'm going to rotate against. I could use an actual axis, I could use a cylindrical face, or even a circular edge. All of them have a center. So that's all I really need. And now I could go and drag on this manipulator here to rotate the rib until I'm happy with the position. Let's go and give ourselves a top view so we could see this more clearly. And let's go and drag this down. And it looks like 30 degrees will be exactly centered. And now I'm ready to go. Now, everything I did so far with direct editing was without any history at all. But if you're someone that comes from a background in parametric design and other software, and you like your history, keep in mind you could turn your history on as well. All you have to do is right-click on what we call the root level, which is the top level of your browser in Fusion. Go to the very bottom and choose Capture Design History. And now you could go and do the same similar edits like you did before. I'll go and do one to this area right over here. And I'm going to rotate using that cylindrical face. And when I go and rotate this time, I hit OK. I now have a feature in my timeline. So now I could go back and edit this feature and change that from maybe 10 degrees to, let's say, 5 degrees. That's perfect. That's just a quick summary of direct editing, but there's a whole lot more inside Fusion 360. So let's jump to the next way you can model in Fusion. This one is called Form, sometimes called Sculpt, and sometimes also called T-Splines. But T-Splines is actually the technology behind what's happening here. So there's an icon at the very bottom, this feature, this purple one here that says Form. I can right-click and edit this. And what you're going to see here is that this organically shaped deer skull or deer head, or if you will, like faux taxidermy, this is made of what we call subdivisions. And these subdivisions are editable. And the real beauty behind this is I already showed you how you can surface model in Fusion 360 parametrically. But when you're surface modeling, you can make what we call coincident edges very easily, where you have sharp transitions from one surface to another. But when you're trying to make the really organic or really complex forms, that could be rather difficult to make those smooth transitions. So this technology, T-Splines, allows you to be able to create what we call G2 surface continuity, which basically just means very smooth shapes automatically. And it allows you to be able to manipulate those shapes very quickly and easily. So when it comes to product design and development, this is going to allow you to be able to ideate on your design very fast until you're happy with the general form. And then if you want to, you could always go back and remodel your design using parametric surface modeling to get a little bit more control over that design. But let's go and take a look at this in action. So here I have what I said was the faux taxidermy. And by the way, this was created by one of my colleagues, Chad Lockhart, after this particular canvas that you're going to see in the background. So all this started with was a picture of a deer, and then take that and turn it into a shape like this. And you could see how it matches very well. But if I want to go and make changes to it, here's the real beauty behind the T-Splines technology. I can select any of these edges, faces, or vertices, or of course multiple, or even a combination of different types, and I can go and edit these to my heart's content. and it will keep G2 surface continuity or very smooth transitions between all of that geometry. So I can come in here and say, you know what? I want to take this antler right here and I want to extend this. I can grab one of these manipulators and extend it, and it will automatically stretch those surfaces and keep that surface continuity. Now, it gets even better because in this particular case, I already have dynamic mirroring turned on. That's the green line you see in the center of the model. And that means that I can come in here and manipulate just one half of this particular antler. And you'll notice that it's going to change on both sides at the same time. And then I can also go and say, you know what? I want to add another antler here. I can go and grab, let's say, this face here, and holding Alt, I can go and drag this material. It'll automatically create a nice transition. And I can take this and also go and stretch it and manipulate it until until I'm very happy with the result. So the idea here is, again, being able to manipulate your geometry quickly to be able to ideate until you're super happy with the result. And I love this technology. This is fantastic for upfront design in your development process. And again, this is called Sculpt, Form, and also T-Splines. I'll go and hit Finish Form. Now, we're not done. In that agenda, we had quite a few other different ways to model as well. The next one is called Generative Design. Let's jump right back into our PowerPoint for a second. And I want to tell you a little bit about what generative design is. So it's a design exploration technology. And it uses, by the way, artificial intelligence to simultaneously give you multiple solutions to your problem that are based on product performance requirements as well as real-world manufacturing constraints. Now, sometimes people confuse this with shape topology optimization, but this is not the same thing. Shape topology optimization is all about taking an existing part and lightweighting it by removing material. And it's typically not manufacturing aware. So you have to remove the material yourself based on your knowledge of the manufacturing requirements. But with generative design, we can add material or remove material, and we do so automatically based on the manufacturing requirements. So a shape that's intended to be 3D printed on your Formlabs printer is going to be very different than a shape that's intended to be CNC machined on a Haas. You're going to get very different results, all based on how you intend to actually make this. And that is incredibly important. Now, the results are actually probably more important than anything. You're able to take something like a motorcycle swing arm you see on the left and turn it into the motorcycle swing arm you see on the right. And we're talking about examples of 50%, 60, 70, even 80% weight savings over the traditional design. That's a very, very big deal. And keep in mind that it does all this calculation in the background, in the cloud for you. Your computer can be an average normal computer, does not have to be a giant powerhouse of a computer workstation, so to speak, to be able to use this technology. That's the benefit of Fusion 360 being cloud connected. Now, let me show you just a little bit more about this because I think you'll like what you see. In this video, you see that same example of the swing arm. The green items here are called preserves. These are geometries or bodies that must be in the final result. So they're really important to you. The red items, those are your obstacles. Let me pause that video for a second. The obstacles are going to be where you cannot have material, right? Because what we're going to do using generative design is we're going to connect all of those green preserves together, and we're going to avoid the red, right? Anything that's in red, it could be a component, it could be a body, it could be geometry that you create yourself, doesn't matter, but you create those obstacles and the preserves, and you specify things like how you want to manufacture the part, what the loads are going to be on the part, and also what materials you're going to make that part out of, or what materials you are considering making that part out of. And after you send it up to the Autodesk cloud, you're going to get not one, not two, but hundreds of different results that you can go and review. And when you select your favorite of those results or favorites, you could then go and compare which one's going to be stiffer, which one's going to be lighter, which one's going to be the cheapest to produce. Right? Not every project is the same. And so you have a balance between performance and cost. Generative design is all about giving you options for you to consider and also to compare against each other. And once you select the right balance between those different Trade-offs, you select your part, you go and download it, and then you could go and additively manufacture. Formlabs would be a great way to do that. Or you can also go and use other techniques as well. So CNC machining is just another example that you see right here. So that's it for generative design, but just know that generative design is all about lightweighting your parts or increasing the stiffness of your parts. And again, it's using artificial intelligence to make that happen. Now let's jump back into Fusion. There is one more different method for designing that I'm going to cover today. And let's do just a quick little time check. Oh, I think we're perfect on our time. Okay, so the next one I wanted to show you is all about mesh editing. Because when you start talking about 3D printing, it's all about that mesh. And so let's jump into my next example. Here I have a mesh that I downloaded. This mesh could come from your own design. It could also come from a website like Thingiverse. But if you take a design like this and import it into Fusion, you might need to edit the mesh itself. Well, you're going to be able to do that. We have what I would call light mesh editing inside of Fusion 360. Here I have my mesh editing feature at the very bottom of my timeline. I could go and edit this. And now that I'm in this mesh editing mode, I have the ability to select individual triangles from the mesh itself. I can change my brush size, so I can select multiple, like a multiple triangles or a bigger area of my mesh all at once. Or I could also change my brush size to be smaller and manipulate just a smaller region here as well. It's really my choice. Now, when it comes to mesh manipulation, we have quite a few different options here for you. You can remesh, you could reduce the mesh, you can close a mesh if it's open. That's especially useful. I use that one pretty regularly. You can erase and fill a mesh, smooth a mesh, cut a mesh. Also, you can delete faces, separate a mesh, or merge it back together, quite a few different things. Now, don't get me wrong, this is not going to replace a true polygon or mesh editor like ZBrush or Modo or Mesh Mixer or a variety of other mesh editing softwares that are out there. But what you can do in Fusion 360 is pretty awesome. And I would say it's especially true when it comes to reverse engineering those meshes as well. But just to show you one example here, I'm going to go and take a region like this one right over here, and we're going to go and just go and delete a couple of these triangles here. So I'm going to go and say I want to delete this region. That's good enough. And then we'll go and modify, and I'm going to say, let's make this a closed mesh again. I can give myself a little preview and see the density of the mesh that it's going to go and create. And once I hit OK and confirm, it's going to go and create that mesh for me. So just keep in mind that we do have the ability to go and edit meshes in Fusion 360 today. Now, I'm actually going to hit cancel. I'm not going to let this calculate because I want to get to the next thing, which is showing you how, once you have your design, you can actually take that and send it to your Formlabs printer. Before I do, one other thing I forgot to mention. There is a 7th method to design in Fusion 360 that I'm not going to be covering today, but I'm happy to send information that we can include on the description of this particular video, and that's going to be about electronics design. So as of January of this year, we've also added electronics design to Fusion 360 as well. So you could design a schematic, also a 2D board layout, and then based on the schematic and 2D board layout, you can actually automatically turn that into a 3D model of your design. And then using that 3D model, you can put that in an enclosure or design the enclosure around it. Of course, 3D print the enclosure would be a great way to prototype it. And if you need to make changes to that design, you can actually make the changes in 3D and push those changes back to 2D. It's pretty incredible. The result, by the way, is that you could make your enclosure be driven off the PCB. So if you change the PCB, it'll actually update the enclosure, or vice versa. You can choose an existing enclosure and make the PCB match that enclosure with maybe an offset. And if you change the enclosure, the PCB can update. That's an incredible technology as well. And that would be the 7th method that you could design in Fusion 360. But let's say for a moment you have your design, and maybe it's something as simple as this bracket, which, by the way, was designed using Generative Design in Fusion. And if I'm ready to 3D print it, guess what? We have a tool in here under Tools, Make a 3D Print, select the object that you're willing to 3D print, and send it to the 3D printer. Now you'll notice here that I have a checkbox here that says Send to 3D Print Utility. If I turn this off and I hit the OK button, it'll basically just output an STL file. You choose where on your computer you want to save that STL file, and then choose a file name, and you're done. But if you want to send this straight to your slicer, you can choose a variety of different slicers, but Preform is a fantastic choice, especially for Formlabs printers. So you choose Preform, which by the way is automatically already built into this list. Choose Preform and hit the OK button. And what you're going to find happens in the background is the Preform software itself is going to open and automatically load your 3D model. So this is going to save you the step from having to choose where you're going to save the STL and what the file name is, open Preform, and then go and load that STL file. Everything that I just described will just happen automatically. So here you could see I have my 3D model coming in, ask me a couple of options here, and I'll just go and say apply. And just like that, I have my model in Preform ready for slicing, ready for sending to my Formlabs printer. That's pretty handy. The next part of this demonstration is going to be my favorite thing to show you guys. I got special permission for the Formlabs audience to give you a preview of a workspace that does not yet exist. And we're calling it Paramesh, and it's going to be a take on the mesh workspace that I showed you earlier, but it is, as my father would say, way more better. And let me show you why. Let's jump right into it right now. I'm going to jump into my dev build, and dev meaning development build. So this is not publicly available today, just to be very, very clear with you. I'm going to go into this dev build, and you're going to see that on the top, I have my solid modeling that I covered earlier, surface modeling that I covered earlier as well. I didn't actually cover sheet metal. I didn't talk about it before, but that's part of the production build as well. And now you could see that I have another workspace here, or tab, called Paramesh. And Paramesh is all about being able to make mesh manipulation parametric. And with that comes a lot of possibilities. So let's go and show you just a couple of things here. I'm going to go and load a mesh body into my Paramesh environment. This particular file is an STL for a motorcycle. This is a disc guard for the rear wheel of the motorcycle. You could see I have my mesh. It's looking pretty good. And I'm going to go and want to make some changes to this. Now, for anyone that's been using Fusion 360 already, you know that the mesh workspace that we have is great to edit the mesh with some light changes. And that's what I covered already. But if you want to go and make some more drastic changes, you have to convert that mesh from a mesh into what we call a BREP. BREP is short for Boundary Representational Solid. I know that was a mouthful, but a BREP is a traditional model that you would make in Fusion 360. So all of the models that I showed you besides the meshes so far, those were BREP models. You convert that mesh into a BREP, and then you could go and make changes. But that converted BREP is pretty heavy because every single triangle in your mesh becomes a BREP face. That's a lot of faces. And we're limited, at least currently, to 50,000 of those faces. So you have some limitations, at least today. But what I'm going to show you in Paramesh are some of basically available technologies that just blow my mind. Sorry, I started to hang up my words because this is the cool stuff. All right, so let's get into it. So the first thing I'm going to do is I'm going to just do a repair on this mesh just to make sure that there's nothing wrong with it. The next thing we're going to do is, now that I brought in the mesh, I'm going to go back to my solid modeling area, and I'm going to create a sketch on, let's say, the front plane here. And I want to make the hole that's right over here bigger. So I'm going to go and create a traditional sketch. I'm going to put a dimension on this circle, and I'm going to say I want this to be 36 millimeters. And then I'm going to go and make a cylinder that represents the cut that I want to make through this particular model. So let's go and do that. Let me zoom out, and I'll rotate just a little bit. I'll change some of my options here, and I'm going to make, this is a BREP solid, that's a cylinder. And how am I going to use this to actually manipulate my mesh? That's what Paramesh is all about. So I'm going to go back to the Paramesh environment, and I'm going to create a, let's go and see here, tessellate my BREP, and hit OK. It's going to turn that into a mesh as well. And then I could go and use my combine tool, choose the original mesh as my target, choose my cylinder as my tool body, And then I'm going to use that to be a cut command. So let's go and choose my cylinder, cut, and I'm going to hit OK. And what you're going to see happen in just a second, it's going to do some heavy calculations. So it might take about 30 seconds. But what it's going to do is it's going to use that cylinder as a cutting tool to cut that hole into my part. So now I have still a mesh body, but it has a much bigger hole, exactly what I wanted. But remember, the beauty behind what you saw today is that it's parametric. So if it turns out that I don't want it to be 36 millimeters, I actually want it to be 40, just as an example, I could go back and edit my sketch, change my dimension from 36 to 40, hit finish, and it's going to recalculate the creation of the cylinder, the conversion of the cylinder into a mesh, and then using that mesh to cut the other mesh. Absolutely incredible. I've never seen anything like this in an engineering platform like Fusion 360. So I hope you enjoy that. And when it's ready, I know you're going to love it. There's one other workflow I'm going to show you inside this tool as well. Let's go and just delete everything besides the start. So let's go and delete that circle, and we're going to delete the extrude and everything else. So now I'm back to where I started. And let's say for a moment that the changes I want to make to this model are just too complex to be able to make the way that I just showed you. I want to truly reverse engineer this mesh. Well, that I could have done before if I had less than 50,000 triangles and I had a lot of time on my hands, because I'd have to do a lot of the conversion manually. But with Paramesh, I could do this all automatically. The next tool I'm going to use here is going to be calculate face groups. And what this is going to do is it's going to take this particular model and it's going to calculate based on flatness and based on curvature, what different areas of the mesh should be like tied to each other. Which other areas are related to each other? It's going to calculate for a model like this for, again, about 30 seconds, and it's going to color those different mesh areas with different colors based on similarities. Once it does that, I'm going to use yet another tool to actually go and automatically reverse engineer this mesh. And that's the real beauty. So let's wait just a moment while that's happening. And while that is happening, I'm going to go and check the Q&A for any questions that Dan wasn't able to answer yet.
Hey, Jason,
I
yeah,
don't
we've got
see any.
those ones from
Oh, please.
Tom there. Might be a good one to start with in your chat window. Just some kind of basic Fusion questions.
Excellent. So Tom, thank you for asking your questions. I see the first one you asked was what solid model or kernel is Fusion 360 based on? Parasolid, ASYS, or something else? And I'll tell you that Fusion 360 uses multiple kernels. That's one of the beauties behind what Fusion does. It's multi-threaded, multi-core, and uses multiple kernels as well. And so depending on what area of the software you're using, it's using a completely different kernel or multiple kernels together. And many of those kernels are entirely proprietary for Autodesk. So I don't have a perfect answer for you, but I guess the short answer is we do use multiple kernels and many of them are proprietary. So we're not using the Parasolid kernel, for example. Also, you asked about whether Fusion 360 runs on a Mac or Linux. You asked, is it only Windows or is it a web browser? So great questions. So let's talk big picture for a second while this is finishing its calculations. So Fusion 360 is available for Windows and also for Mac. And the application in both cases is identical. Right? So your experience on either will be identical to each other. You can also use Fusion 360 in a web browser, but if you do use it in the web browser, I will admit it is quite limited in its functionality. So I would recommend you install the desktop application on Windows or Mac, but we do not have a desktop application for Linux at this time. So it is Windows or Mac. We also do have an iOS app and an Android app for your fancy smartphones or your tablets, but those devices are going to be for view only, not for actual creation of your designs. So just be aware of that as well. And then last question, you asked quite a few questions, but I'm glad you did. Ballpark price. The retail price for Fusion 360 is $495. And that's going to be per person, not per computer, and it's per year. So it's a subscription. Very similar to, let's say, Adobe Illustrator or Adobe Photoshop or any of the Adobe products. for that matter. In fact, all Autodesk products these days are subscription. We try to keep our prices as low as possible so that it's affordable for anyone, whether you are someone that's designing things at home just for fun or in a commercial application. Right? And if you are a student at an accredited school or university, Fusion 360 is completely free. And that's not a limited version of the software, that's the full version of the software. Now that was quite a few answers, and actually Fusion finished all of its calculations a few moments ago. So let me show you the next part of this magic. And this is where the really fun stuff happens. So I calculated those face groups. You could see here all those different colors on my screen. Now I'm gonna say I want to convert this back into a BREP body. I select the particular mesh that I want to convert, and we have a few different algorithms to help you do this, but I'm going to choose Prismatic, and I'm going to hit the OK button. And what you're going to see happen in just a second, and I just can't stress this enough, it's magic. I'm so proud of the Autodesk development team for being able to do what you're about to see, is that it's actually going to convert this model back into a BREP. And this is the exact kind of model that you might have designed yourself in Fusion 360, or in Rhino, or in SolidWorks, or in Creo, or in Onshape, or anywhere else. And that means that you can download STL files, or OBJ models, or FBX models from any number of sources and be able to reverse engineer them as quickly as you just saw here. And now that I've done that, now I could use my direct editing, my solid parametric modeling, my surface parametric modeling, or any of my other techniques to go and edit that. So it's pretty incredible. And it's not available today, but I'm hoping it's going to be available soon. I'm not allowed to promise any dates in particular, but I just wanted to give you a preview so that you can get quite excited for it, because I know that this is the exact kind of technology that Formlabs customers are going to love. That's it for this particular preview. There's only one more thing left on our agenda, and that is to talk a little bit about Netfabb. And if you don't know about Netfabb, it is a slicer by Autodesk, and it's a great supplement to the slicer you're already using with Preform. Right? You can use Preform, you could use Netfabb, or you could use them both together. Now, I'll admit I am not a Netfabb expert, so I brought in one of my colleagues, Andreas. He is on vacation this week, so he was kind enough to pre-record a video for all of you. I'm going to go and play that, and then I'll be back right after to be able to answer any of your questions. So please hold on just a moment while I play that video for you.
The following video demonstrates how you can achieve full control over your SLA builds using Netfabb in addition to Formlabs Preform. It includes specific use cases that show how you can easily maximize your Formlabs user experience. Hi, my name is Andreas Niculescu, and I'm a technical sales specialist additive manufacturing here at Autodesk. I am very happy to guide you through the next 10 minutes. Before we begin, I would like to introduce Netfabb. Netfabb is our end-to-end solution for any kind of additive manufacturing workflows. It can cover pretty much anything from CAD import over latticing and optimization to repairing and even support generation and/or simulation. Our included connections to the most important 3D printers, such as Formlabs, allow out-of-the-box build-export capabilities. In the following, I would like to give you 4 very common use cases in which Netfabb can provide a quick and easy solution to your problem. So we are starting right here in Netfabb with our Formlabs Form 3 already open. As we can see, we already have 2 parts in our build. Apparently, there is an issue with one of the parts, as we have this very big warning sign right here in the bottom corner. Our platform overview shows us that our dental piece right here has an incorrect mesh and requires fixing. As you can see as well, the part is basically just an open surface that we got right from the dentist. If we want to print it, we would have to prepare it to a closed mesh. First of all, we're going to reduce the size of the model, as we are mostly interested in the teeth and we do not want any of the remaining gums. So we can basically cut it off right away. After cutting the sides, we also want to cut the part horizontally to prepare the foundation that is going to be created in the next step. In the repair module, we can now see how the big yellow edge is defining the open contour of our part. First, we are going to remove all noise shells that may be a side product of our cutting activities so far. The main part here in this module is the extrusion in Z direction so that we can get a good enough base for our solid model. After the extrusion, we have enough material that we can work with to create a solid. We can use a plane to cut and stitch the parts and by that finish our fixing process. As we can see, the part is now a closed solid model. That means our fixing process was successful. But that also means that we now have time to look after the other part in our build and see how we can improve that as well. The second part in our build is this simple bracket. As it seems, the support that we find on this part is rather massive, and by that consumes quite a bit of space on our build platform. I would propose that we take a look and see how we can optimize our support in a way that it still holds the part but can be produced faster and more effectively. In order to do so, we have entered our support module, which gives you access to a variety of different support types. These can be defined manually or fully automated using customizable support scripts. Scripts contain many different settings that include clusters. These are basically defining the areas that require support, and the support types and geometries itself. We're now going to choose a support that uses a bouquet or a tree support structure instead of this adaptive lattice. This is going to save us a lot of time and keep the support as strong as we need it to be. As our current parts are now repaired and supported, we should probably add more parts to fill our build platform. Let's see how that works. I would like to go for a simple impeller that I have created earlier on in Fusion 360. As you can see, Netfabb accepts a variety of different file types, not just mesh types such as 3MF or STL, but also the most important CAD types such as Inventor, CATIA, NX, and of course STEP and IGES, you name it. Working with CAD files is one of my favorite things to do in Netfabb. During the import, you may define the tessellation level of your part. This is going to define how accurate your model is represented in Netfabb. Let's take medium accuracy for once, which is going to save computing capacity. Typically, you would now go ahead and perform all of your different activities based on this tessellation level. As soon as you finish your data preparation, you can always go back and retessellate to a higher level so that you can export using the best possible part quality. I think we might have one more part to work on. I have added another bracket to our Form 3. As you can see, this one is pretty large and bulky. It is pretty much going to consume a lot of build time and resin as well. Therefore, I would like to facilitate printing by applying a lattice to the part. I have already made some preparations up front. I have divided the parts into different segments that will now go into Netfabb's lattice commander, easily via drag and drop. In here, we can now specify which of these parts are going to be used as a lattice, as a skin, or as a full volume. Let's start with a small part here on the left. This one I would like to be kept as is, full volume, so no changes here from our side. The larger part, however, is first going to be replaced by a lattice. With Lattice Commander, you have the ability to use a variety of different lattice geometries that can be applied in different sizes, thicknesses, angles, and so on. The lattice itself can also be edited. I'm going to show how to automatically delete all open beams so that all beams are connected to a main grid. This is also going to reduce the amount of beams that exist. The lattice itself is not really helping us at the moment as we are missing the outer geometry of the part. For that we are going to create 2 additional skins on top of our lattice. We are able to delete faces that we do not require so that the lattice can be exposed to the outside and the resin can flow out. We want to do the same thing for the small geometry here in the center. The only difference is that we want to treat it as a whole later. No lattice should be penetrating this geometry in the final component. When everything is set, we are ready to create a new component based on our skin and lattice combination. We can now take this to our Form 3 and replace its predecessor. With all of our parts now being prepared, it seems our build is ready to go. Our last step in Netfabb is the export in the .form file format that can now be sent to your printer using Formlabs Preform. In summary, we have seen 4 different ways how Netfabb can enrich your Formlabs workflow, helping you to get full control over your parts and processes, either by fixing files, applying different kinds of support, using CAD file formats, or adding complex lattice geometries. Thank you very much.
Hello again, this is Jason. I'm going to stop my screen share and turn my video back on. Give me just a moment while I get that done.
I'm back as well. Thank you to Andreas in absentia for that, for that video.
So I saw you ask quite a few questions on the Q&A. I did my very best to answer as many as I could during this particular 10 minutes Andreas was talking. Are there any other, Dan, that you saw in particular that I can answer on the spot?
Yeah, let's see. So we've got a couple in here that are sort of about, you mentioned a lot of the calculations for Fusion are done in the cloud. Got a couple questions here, one from Anonymous, one from Joris, but asking, one, does the Fusion 360 use GPU acceleration? If so, is there a minimum requirement? And similar question from Anonymous asking, their performance isn't quite what they want it to be when working with a Formula Car file, and then they give their specs. Can you give any suggestions on how to maybe improve performance?
Yeah, let's talk big picture for a second. So I talked earlier about how Fusion 360 is a desktop application, but it does use the cloud for connecting to files, for example, connecting to other people for collaboration, and then for the really heavy lifting, that's where the calculations are done in the cloud. But the majority of the work is still done locally. Now, when it comes to things like minimum hardware requirements, Fusion 360 makes it easy. Remember, this was created recently and not then. Right? So we're talking about using just an average computer is perfectly fine. We do have minimum hardware requirements that are listed online. Generally speaking, I don't recommend that you buy a computer that's new that just barely meets those requirements. A better computer is going to give you a better experience. That being said, what I don't recommend is you going out and spending $4,000 on a crazy workstation. You won't need to do that. When it comes to Fusion, it's all about just buying a computer that has good performance. This computer I'm using today is a Core i7. I feel like Core i7s do very, very well. It has 16 gigs of RAM. I honestly wish I had 32. But if you look at the minimum hardware requirements, it'll say something like 3 gigabytes or 4 gigabytes of RAM is the minimum. And that's really just the minimum for it to open. Again, I personally recommend 16 or higher. I'd prefer 32, but I wouldn't go crazy and get 64. And the other thing to note is that you don't need to go and look for a certified list of graphics cards. You just go and buy whatever graphics card you're happy with. And if you know enough about graphics cards to know all the model names and things like that, then you probably already have a preference on what kind of graphics card you want. So just go and buy that one.
Awesome. Yeah, I think that's a good way to go. We've got another from Tom who asked those questions before, and I think this is another good one. So Fusion 360 will allow both history-based modeling like SolidWorks and Creo and direct modeling like Space Claim. Is that right? So just a confirmation of
That's correct.
Those two things.
Yeah, I said earlier that Fusion 360, the name Fusion, is all about fusing together different design methods. So Dan and I can work on a project together, and he could be all about solid modeling, and I could be all about surface modeling, and we can work on the same file. The same is also going to be true between parametric modeling and also direct editing. You can do direct editing by itself with no history whatsoever. You can also do direct editing with the history turned on, and they all work together quite seamlessly. And then there are certain environments like the mesh workspace and the form workspace that are what I call quasi-parametric, in the sense that when you enter those workspaces, everything that you do while you're still in that workspace is not parametric at all. But when you leave that workspace and you go back to like the main area, you're back to parametric modeling, and what you created in that form environment can still be acted upon parametrically. So let me just give you an example to make more sense. You can create the shape of an enclosure using the T-splines method I showed. And then when you exit out of that area, it converts that surface into a traditional B-rep. You can thicken it, you can add ribs, you could add holes or bosses or anything else you'd like. And if it turns out that you need to make a change to the surface shape, you could go back into that T-splines area, change the shape. The changes you make while you're in that area are not exactly like recorded, but when you exit, the rest of the history will still be completed. So it will still thicken that part and add the bosses and the ribs and the holes or anything else you did.
Got it. Awesome. I'm going to fire out 2 Netfabb questions. If neither of us can handle them, we'll pass them along.
I'll admit I probably can't.
That's cool. Will Netfabb work with multiple machine types? I think I can answer this. It's not just Formlabs. Netfabb is a pretty...
That's correct. Netfabb is a universal slicer, and so you can use it with a variety of different machines, both plastic as well as metal, and there are very specific brands and models that it will work with. But in general, Netfabb is an all-in-one slicer, so pretty much regardless of what machine you're using, it will likely work.
Yeah. And I'll mention that our preform software uses sort of the APK from Netfabb to do a lot of the slicing stuff in it. So that's why we have a pretty close relationship on that particular thing. The other question was, and I think this person is asking, can you really edit the mesh in Netfabb, or is it more for repairs and things like that? That's a good question. I believe there are some light modeling tools, but I would say do what you can before it gets to Netfabb, because that's really meant to clean it up before printing. Does that
I'll agree with that, and I'll also add, depending on your phrasing of it, like something like latticing is very much editing the mesh. Some people would say that you're just taking the mesh and basically hollowing it out, but you're not really changing the shape. But latticing, in my opinion, is changing the shape. So you do have some light mesh editing, but again, Netfabb is not going to be Modo, it's not ZBrush, it's not one of those polygon editors. We have a variety of those softwares available, even within Autodesk products, like Mesh Mixer and Mudbox and 3ds Max and Maya. They all manipulate meshes, but our competitors also have great software for that as well. All right, so Netfabb, sorry, I keep confusing the two. Netfabb is meant to be the last step before printing.
Yeah. Great question here from Aaron. In Paramesh, would you be able to make a smaller hole in the example you had up, or is it limited to intersections of the mesh and the created B-rep body?
I'm not 100% sure yet. I've only started playing with the Paramesh workspace just recently. It was released for Autodesk employees to start playing with it and beta test it, so to speak. So I don't yet fully know all of the capabilities, but I just wanted to show you today 2 of the workflows that I thought you might be excited about. But I'll tell you that the 2 that I showed you are not the only 2 things that you could do there. There were a lot of other buttons that I did not click on, but I think when it does go into production, you guys will all be pleasantly surprised with what's available.
Mhm. And I know for me personally, I'm an old school Maya user. That's what I learned on, and like the Boolean subtract, which is a sort of analogous feature, could really wreak havoc on a Maya mesh. So
Yes.
seeing it play nicely in that is really cool. David asks a great question. I remember ArtCam was able to take a bitmap file and convert it to
Ooh.
3D. Can Fusion 360 do something like that?
Unfortunately, not yet. I know exactly the feature that you're talking about. It was one of the coolest things that ArtCam did. Unfortunately, it is not yet in Fusion 360. And I always say yet because I am blown away by what the development team at Autodesk for Fusion 360 is able to accomplish. But I don't know if it's in development, and it's certainly not ready today, but I don't know where it would stand or if it's being worked on, unfortunately. But that was a very useful feature. I agree.
Awesome. I think this will be a great last question, Jason, but someone was asking, where can they find more resources to learn more self-paced study for
Ooh.
Fusion or Netfabb or anything else from Autodesk?
Great question. I'm going to actually share my screen again to show you all the different ways you could learn Fusion. Let me just pull up Fusion again real quick while I do that. Just a moment, please. Perfect. All right, so we're back in Fusion 360 itself. Now, the links that we're about to use, I'm showing you from Fusion, but you'll see that these are just going to open up web browsers, and you could save those links as well. So if you go to Help in the top right corner here, there are a couple of things to keep in mind. The Learning panel is a context-aware menu that is going to give you goals for things that you should try. This is especially useful when you're an absolute beginner. So it's going to say, try creating a solid body, try creating fillets, try creating a cylinder. And once you've done those things, you're going to get a checkbox. Think of those like gold stars from your teacher way back when. This learning panel, though, is context aware. So as you get more advanced, the learning panel is going to show you more advanced options as well. If I close that for a second, let's go and take a look at that help panel again. I go to Help, Learning and Documentation, and you're going to see these 2 options at the top are fantastic. Self-paced learning is going to take me to an area of our website. You're going to see here that you're going to have, this is really just the Autodesk Fusion 360 webpage or landing page with the Learn and Support button already clicked. And here you're going to see Getting Started for Absolute Beginners. These are going to be your most beginner-friendly courses right here at the top. Getting Started in Fusion, Administration in Fusion Team, which is really just data management, how the basics of sketching and how to start 3D modeling. Each of these courses is scripted and edited. They come typically with files for you to follow along with so that you can go and watch the video and follow along as well. As you go down further, you're going to find more and more classes on more advanced topics. Everything from sketching and parameters, advanced part modeling, direct editing, which I showed earlier, and a whole lot more. As you get on further, generative design, you're going to find product design and development, including ECAD classes, because I didn't really show ECAD. I was going to run out of time. Simulation and even CAM. Right? All of these classes are available and they're all free. So even if you don't have Fusion, just go to this web address, right? Again, all you have to do is go to the Fusion 360 page and click Learn and Support. The other area that I think is really helpful, let's go back there to Help, Learning and Documentation, Product Documentation. Now, product documentation is really an instruction manual, but for some reason, everyone is always scared of the words instruction manual. So we don't call it that, we call it product documentation. You can scroll through here and you'll find everything from designing with solids, designing with form, concepts, how-to, and even tutorials. But I don't recommend you just go to this instruction manual and click around. What I do recommend is that as you're designing, let's say I'm in solid modeling and I go to create even something as simple as the extrude command. If I'm not sure what to click on or what these options mean, look for the black circle with the I in it. That I stands for information. Click on info and we'll give you some tips and tricks. But if you scroll down here, this little button that says more info is the best. Click on more info and it'll take you to the exact right page in that instruction manual. They will include descriptions or videos to show you that you can follow along with as well. And then at the bottom, you'll even see other topics that you should take a look at as well. The very last thing I'll tell you though is that our YouTube channel is fantastic. So if you go to youtube.com and you just do a quick search at the top for Fusion 360, you're going to see that we have a very strong following. We have 171,000 subscribers and over 1,000 videos on a wide range of topics. So come and take a look at our channel. You're going to find we have videos in multiple languages on multiple topics. We start off with essentials for new users, quick tips for more advanced users, or just people that already know how to use Fusion, at least the basics. You can also find we have different playlists on topics like CAM, we have popular uploads, and if you come from a software like SolidWorks, we even have top 10 tips for SolidWorks users as well. Now, if you happen to really like me in particular, you could find me on this YouTube channel as well. Just do a search in this little search box instead of at the top. You can search for any topic you'd like. You could even search for the name Jason, and you'll find all of my videos and, of course, little thumbnails of me all over the place as well. But the point simply being, this YouTube channel is fantastic. Really take a look there. I think you'll be very happy with what you find. And don't forget that as you're watching those videos, practice makes perfect. I bought a ukulele a couple of years back and I watched a bunch of videos, but I never really spent the time to put that ukulele in my hands. And guess what? I can't play it to save my life. Please don't ask me to play anything. So it's all about watch a video and then practice and then share what you learned and also share what you made on our Instagram, on our Facebook. Please share it with everyone. Right? We have a Facebook page that's quite popular as well. Feel free to join that user group.
Awesome. Thank you, Jason. That was a perfect run through. And thank you so much to everyone who's watching. This has been really, really fabulous. Jason, great presenter, really good information. And yeah, like I said previously, a recording of this will go up shortly afterwards. If not, right afterwards, we'll have it on our YouTube channel in the next week or so. So Jason, thank you again. I really appreciate your time. And yeah.
Oh, it's my pleasure. Oh yeah, one more thing. If you are looking at Fusion 360 for a commercial application, you're a business and you're considering using Fusion to either replace your existing CAD or to supplement it, or because you have no CAD at all, we are happy to help. You can reach me directly using fusion360demo@autodesk.com. And we'll make sure to put that email address in the description of this video as well. But again, that was fusion360demo@autodesk.com.
Awesome. Thanks so much. Everyone, thank you so much. Have a great rest of your week. We'll talk to you soon and we'll see you for the next one. And yeah, have a good afternoon.